So, good day everyone. So, for today's lecture, we will answer the Seatworks that I gave you previously. So, this is the last part of our discussion about expressing a force into Cartesian vectors, and this time we will use position vectors. Hopefully, on the previous video, you have learned how to express a force into Cartesian vectors if the given are position vectors. So previously, on the first two lectures that I did, so we only have angles. So for the first part, I discussed how to express Cartesian vectors if alpha, beta, and gamma are given, and of course the magnitude of the force into a force vector. So using these four given, how will you express the force into a Cartesian vector? So to do that, we are using the formula of force is equal to what is the magnitude times its unit vector. The magnitude is given, so therefore your task is also to find what is the unit vector. Since alpha, beta, and gamma are given, you are going to use the formula of unit vector using alpha, beta, and gamma, in which that is cosine alpha I hat plus cosine beta j hat plus cosine gamma k hat. So that is how to express a force into Cartesian vector using the alpha, beta, and gamma. Now on the second part, in which the given are the transverse angle, so that is the yellow one, the theta, and the azimuth angle, so that is the purple one, which is phi. In that case, if the given are, again, so that is transverse, phi, and also, of course, the magnitude should be given. So, if these are the given and we have to express again our force into a Cartesian vector, what we're going to use is the formula of our F here is equal to Fx I hat plus or minus Fy j hat plus or minus Fz k hat. So that will be the formula in finding the Cartesian vector. Okay, and do not forget, so what you're going to do here is you will find Fx, Fy, and Fz individually, and note that you have to indicate the sign positive or negative manually, okay? Because in finding the Fx, Fy, and Fz, so we can only get the magnitude. So you have to look on the diagram or to the free body diagram for its sign, okay? Now for the last part of our discussion on Cartesian vectors, this is expressing Cartesian vectors using position vectors, in which the positions are given, saying these are the dimension of this point from the origin. Okay, so what will be the distance of that point from the origin? So we will get its position or its distance x1, so that is the distance that point from the origin to along x-axis. Next, y1 is the distance of that point from the origin along y-axis. z1, what will be the position of that point from the origin to z-axis, and the same with the point 2, okay? In which in point 2, that is also the distance from the origin along x-axis. y2 is the distance from the origin along y-axis, and for z2, that is the position or the dimension of our point from the origin along z-axis. So if this is the vector, so the vector starts from origin and it ends at this point, so you have to note that whatever the tail of a vector, that is the origin, so that is the position 1 or position A in some cases. Now whatever the head, okay, the head points to the last destination or the final point. So it means if I will get the difference of these points, it will be green dot minus the orange dot. Okay, so using these points, we will come up with its position vector. So in which position vector, that is R, is equal to Rx I hat plus Ry j hat plus Rz k hat. So that is our position vector. To get Rx, all you have to do is to subtract x2 minus x1. Okay, remember, the head is the final position, the tail is the initial position. So that is final minus initial position. So how to get again Rx? So that will be x2 minus x1. How to get Ry? So that is y2 minus y1. And how to get Rz? So that is z2 minus z1. So what we're going to do is we have now the position vector. And from the position vector, we will extract the unit vector, because the force vector is also in the same position or in the same direction with the position vector. So they are sharing with the same unit vector, because unit vectors tells us the direction of a certain vector, and since position vector is also the position of our force vector, so they are sharing with the same unit vector. So from here, from position vector, we will extract the unit vector, and using that unit vector, we will now come up the formula for our force vector, in which that is, we will just multiply the given magnitude of the problem times the extracted unit vector coming from the position vector. So hopefully this is clear for our discussion. Okay, so let's answer this one. So determine the position of point A and point B in each problem. So what is the position points of point A and point B? And we will also determine the position vector, the magnitude of the position vector, and also its unit vector. So from here, this is our point A. So all you have to find the distance of this point from the origin in the 3 axes. Okay, so first, this is a point A. So what is the distance of this point A from the origin? So this is the origin. Okay, so I need this distance. So that distance is 5 meters because this is x-axis. So that is 5 meters. Now, we have to check also if this is positive x or negative x. Since it's lying along positive x, so this is positive. Now, what is the dimension of this same point along y-axis? Okay, so this is point A. If we will look, this is the origin and this is the point. Since it's not moving along right or left, so therefore the distance of that point A to y-axis is 0. Okay, and lastly, what is the distance of this point A to z-axis? That is from the origin then along z-axis. So if we will see, so that point has no distance going up or going down along z, so that is also 0. Okay, so that is our point A. For point B, so we will start again to x-axis. What will be the distance of this point B to x-axis? So this is our point B, and we will look. So as you can see, there is no distance from the origin to point B, so there is no forward or backward dimension of that point B, so that is 0 meters. And for y-axis, okay, of this point B, what is the distance of that point B to y-axis from the origin? So this is the origin, and this is the y-axis. So that will be 3 meters. Okay, is that positive or negative? So we will check. So this is positive y again, and this is the negative y, and that dimension is lying along positive y, so we will put positive. And lastly, so what is the dimension of this point B along z? So that is from the origin along z, so this one. So that dimension is 2 meters. And we have to check if it's positive or negative. Since our dimension or that distance is lying along negative z-axis from the origin, so that is negative 2 meters. So these are now our position points. Now our next task is to get its position vector. So from position vector, so that is A, B. Since there is no arrow vector here, okay, so we will assume that A is the origin and B is the head. So that is B minus A. So in that case, if it's B minus A, so to get Rx, I hat plus Ry, J hat plus Rz, K hat, all we have to do for Rx is x2 minus x1. So that will be 0 minus 5. So that is negative 5 meters, I hat. Then 3 minus 0. So that is positive 3 meters j hat. Then negative 2 minus 0, so that is negative 2 meters k hat. And or we can write it this one just like negative 5 I hat plus 3 j hat minus 2 k hat, and do not forget the unit, which is meters in this case. Now from this, we will extract the magnitude of our position vector, in which that is RAB, and the formula of that will be square root of Rx squared plus Ry squared plus Rz squared. Square root of 5 squared plus 3 squared plus 2 squared, so that is square root of 38 meters. And for its unit vector, so this will be the last step since there is no given magnitude for our force. Remember, a position vector is also a vector, okay? That is also a vector, so that is a Cartesian vector. So if we will have here a force, so this is a position vector, so that it starts from A going to B, so that is our force, okay? In this case, since there is no given magnitude for our force, so we will assume this vector is a position vector, not a force vector. So if we will get the unit vector of that, the formula for the unit vector is just what is the position vector RAB divided by its magnitude AB. So therefore, that will be negative 5 over square root of 38 I hat plus 3 over square root of 38 j hat minus 2 over square root of 38 k hat, and that will be unitless. For the unit vector now, since this is the final answer, so we will come up with a 2 decimal answer. So in that case, that will be negative 0.81 I hat plus 0.49 j hat minus 0.38 k hat. Now this is now the unit vector, this is the magnitude, and this is now the position vector for letter A. For letter B, since we don't have the magnitude of a force, so we don't have a force vector here. So let's go to point A first. So again, so this is point A. All you have to do is think what will be the distance of this point from x-axis. So all you have to do is look on the x-axis and you have to find the origin. What is the distance of that point from the origin going to that point along x only? So this one. And in that case, for that one, that distance is 1 meter. And that is 1 meter. Now, we have to check if it's positive or negative. Since this is positive x and this is negative x, and that dimension is at the back or on lying along negative x-axis, so that is negative 1 meter. For the dimension of that along y, so this is y-axis, so this is the dimension of that point from the origin going to that point, and that is 4 meters. And again, so this is positive y, this is negative y, so that should be negative. And lastly, so what will be the dimension of that along z? So to see this better, so we can have a dot line here that will connect the z-axis to that point. And this distance, we have to find this distance, and that is 3 meters. And we will check again if it's positive and negative, since this distance or this dimension is going up to positive z, so that will be positive. So we have negative 1, negative 4, and positive 3 meters. We will get again the distance of point B from the origin. So that one, this one is point B, and this is the origin. So what is that distance? So that is 3 meters. And is that positive or negative? So this distance is going to positive x, so that is positive 3 meters. Then along y of this distance, so this is the dimension of that along positive y, and that is 4 meters. So that is 4. And is it positive, negative? So since it's going to positive y, that is positive 4. And lastly, what will be the dimension of that along z? So if we will look, there is no distance of that going up or going down. So the distance of that along z is 0, and the unit is meter. Okay, so position point B is 3, 4, and 0 meter. Since we already completed the points, we can now solve for its position vector, which is our AB. Now for that, so again, we will imagine that we have a position vector here, which starts from point A and ends at point B. So that will be our force. So that will be x first, so that is 3 minus negative 1, so that is 4 I hat. Then, for Ry, so that is 4 minus negative 4, so that is positive 8 j hat. Then 0 minus positive 3, so that is negative 3 k hat. And the unit of that is meters. For the magnitude of RAB, we have, for the magnitude of that, so that will be square root of 4 squared plus 8 squared plus 3 squared. So no need to write negative since this is squared and that is meter. So what will be the answer of that is square root of 89 meters. Now for the unit vector, the last part, since we don't have the magnitude of the 4, so 4 divided by square root of 89 I hat plus 8 divided by square root of 89 j hat minus 3 over square root of 89 k hat, and that will be unitless. So that will be 0.42 I hat plus 0.85 j hat minus 0.32 k hat, and that will be the answer for letter B. For letter C, so we have here, again, we will find out what will be the point A. So that will be, for x, what will be the dimension of that along x? So this one is x-axis. So this is x-axis, so I have to get this dimension. And based on the diagram, that is 3 meters. And since this is lying along negative x, so that is negative 3. Next, what will be the dimension of point A along y? So this is our y-axis, so I need this. And that will be 1 meter. And that is lying along positive y, so that is positive 1. And lastly, what is the distance of this along z? So again, if I will get a dashed line here connecting the z-axis to that point A, so I need the dimension of this. And in that case, that is 4 meters. And since that distance is lying above the origin, so that will be positive 4 and meters. Okay, so that is for point A. For point B, so that will be, what is the distance of point B along x-axis? So this is x-axis, then I need this. And that will be 3 meters. So that is positive because it's going to positive x. Now, what is the distance of point B? Again, along y-axis. So this is that dimension, and that is 2 meters. And since that is on the left side of the origin, so it means it's negative 2. And lastly, for z, and this point has no distance going up or going down, so for z, so that is 0 meters. So since there is no magnitude for the force, so we assume that this is a position vector. So it starts from A and going to B. So in this case, our position vector RAB, so we will compute. So this is B minus A, so 3 minus negative 3, so that is 6 I hat. Negative 2 minus negative 1, so negative 3 j hat. 0 minus 4, so that is 4 k hat, and that will be meters. Now for the magnitude of our position vector, so that is 6 squared plus 3 squared plus 4 squared, that is meter, and that is square root of 61 meters. And for the unit vector, so that will be 6 over square root of 61 I hat minus 3 over square root of 61 j hat minus 4 over square root of 61 k hat. And since there is no magnitude, we will have the final answer. So that will be 0.77 I hat minus 0.38 j hat minus 0.51 k hat. Okay, so that will be now the unit vector. Now, before we proceed on the next part, if you will observe, our unit vector here is positive, negative on j, and negative on k. Now, I taught you last time that whatever the sign of the unit vector, that is also the sign of our vector. Okay, so that is positive I, negative j, and negative k. Now, if you will look our vector here, so you cannot imagine if your answer is correct or wrong. Actually, in this case, since our vector didn't start from the origin, okay, so you might be confused, but don't worry, your answer is correct because our vector is just so the sample our examples here, it's just happened that our example here didn't start on the origin. Now, if I will move this position vector so that it will start from the origin, so that case, so I will move it here. Okay, and as you can imagine, if we will trace here, we will put some dotted lines here. So this vector lies on positive x, negative y, and negative z. So that is the same with our direction of our unit vector. Let's see if that is also true to the problem B. So again, if I will move our position vector so that it will start on origin. So here, our position vector is positive x, positive y, and negative z. So since it's going down, which is also correct to the direction of the unit vector, positive I, positive j, and negative k. And lastly, so if we will check it to our first problem, so that it will start again to the origin. So you can see our vector here, which is negative x since it's at the back, positive y, and negative z. So that is negative I, positive j, and negative k. So therefore, this is also a correct direction of our position vector. So hopefully, this concept is clear to you before we proceed to solve force vector using position vectors. So let's proceed to letter D problem. So this is our point A. This is now point B. So since our vector starts at the origin, so our point A is 0 on x, 0 on y, and 0 on z. While for our B, what is the distance of this point B along x? So this is x axis. So what is that distance? So that is 2 meters. And that is along positive x, so that is positive 2. And what is the distance of this point along y? So that 1. So that is also 2 meters. And what is the distance of this along z? So if I will make a dotted line again here, and that 1. So it's also the same with this. So that is 1. But since this is going down or below the origin, so that is negative 1. Okay? So hopefully that is clear. So we will have again your RAB. So that will be, so this will be easy since it starts from the origin. So that is 2i hat plus 2j hat minus k hat. Okay, and for the magnitude of that, 2 squared plus 2 squared plus 1 squared. So that is square root of 8 meters. And for its unit vector, so that will be 2 over square root of 8 I hat plus 2 square root of 8 j hat plus 1 square root of 8 k hat. And the answer for our unit vector is 0.71 I hat plus 0.71 j hat and minus 1 over square root of 8 k hat and 2 divided by square root of 8, so that is 0.71 I hat, And the same with that, 0.71 again, j hat. And that 1 divided by square root of 8, so that will be 0.35 k hat. Okay, so again, so our position vector is on positive I, positive j, and negative k, which is true here. So that is positive x, positive y, and negative z. Okay?